Hello everyone, this is Chandrashekhar welcoming you all to the wonderful Sunday Ka Funda series. As you all know, in this series, we first demonstrate or show the application of an important concept and then we discuss the theoretical concept behind that application. So in today's session, I am going to discuss about the concept of air drag or the air resistance and the terminal velocity. Alright. So guys, please do let me know if we drop an elephant or a mouse from a height, which will touch the ground first? Definitely your answer will be the elephant because it is having more weight. Let us try to understand this concept through a very simple experiment.
Go.
Now I am having a piece of paper and a diary of same shape and same size. Now if we drop these two together on the ground, which will touch the ground first? Let us find it out. Same height. You will say that the diary is having more weight, that is why it touches the ground first. Let us take two pieces of paper of same size, same shape as well as same weight. Now what I will do is I will fold one of the paper to make it a ball. Now both are having same weight. Now if I drop them together from the same height, then which will touch the ground first? Let us see. So what happened in this case? The air resistance played an important role here. Now try to understand how the air resistance affect the motion of the body. Now if I take the same piece of paper and the same diary, but now I am putting the paper over the diary. Now if I drop them together, then what we will see? Let us try to find it out. Both had reached the ground at the same time. Why? Because now the air was unable to apply the drag or the resistance on the piece of paper. Alright? It is not because of the weight of the diary. Diary was kept below the paper. So the diary is not exerting any force on the paper. But the air resistance could not play its role. So let us try to find out the concept, theoretical concept behind this. Hello everyone. So welcome back. So let us discuss the concept of air drag, air resistance and the concept of terminal velocity. So let us find it out. So whenever a body is dropped in a liquid, there are two types of forces which are acting on the liquid. One is the drag force. What is the drag force? The drag force is the resistance force exerted by the moving fluid on the body. Due to relative motion, it always opposes the relative motion. So if the body is moving in downward direction, the drag force will be acting on the body in upward direction because of the relative motion. So let us write it as CD, coefficient of drag, into area, projected area, into rho into relative velocity square by 2. That is the drag force which opposes the relative motion. And other than that, weight of the body is acting in downward direction. That is W, M into G. And also because the body is completely immersed in the fluid, one more force is acting, that is called as buoyant force. What is buoyant force? Buoyant force is equal to the weight of the fluid displaced by the immersed body. That is the pressure force which is exerted in upward direction. That according to Archimedes principle, we can say density of the fluid into G into volume of the displaced fluid. So these are the three forces which are acting on an immersed body. So let us try to find it out. Let us try to understand the concept of air resistance or air drag. When a body is immersed in a fluid, so once the net force becomes 0, net force in vertical direction becomes 0, then the acceleration will be equal to 0.
and acceleration becomes 0, so we can say the velocity becomes constant. This maximum constant velocity which is attained by the moving body is nothing but called as terminal velocity. This is called as terminal velocity. All right. So let us try to find out how the body achieves the terminal velocity and what is its significance. For an example, if a body is dropped in a liquid, a body is dropped in a liquid. So initial velocity of the body is equal to 0. And if the initial velocity of the body will be equal to 0, the drag force will be equal to 0, because drag force, I have already told you, it is directly proportional to u square. So the drag force exerted on the body will be equal to 0. And the weight of the body is acting in downward direction and the buoyant force is acting in upward direction. Right? Weight and buoyant force. Drag force is equal to 0. Because weight is greater than buoyant force, the body is having an acceleration in downward direction. The body, due to acceleration, due to gravity, the body will have an increase in velocity. So if the velocity increases due to acceleration, due to gravity, due to g, so the drag force also increases. The drag force will also increase. The drag force will keep on increasing on the body. At some moment, at a particular moment, the summation of buoyant force and the drag force will be equal to weight of the body. At a particular moment, when the net force acting on the body in vertical direction becomes 0. What does that mean? When the sum of drag force plus buoyant force is equal to weight of the body, then the acceleration will be 0 or u becomes constant. So the body will continue moving with the terminal velocity, and that is the concept of behind the safe landing of a parachute. Because once there is an acceleration, the velocity keeps on increasing in downward direction due to gravity, then after some time the net force acting on the body becomes 0 and the body will attain the terminal velocity. It means there will be no further motion of the body, or there will be no further acceleration on the body. All right. So we can find out from this expression, we can easily find out CD into projected area of the body into rho into u maximum square by 2 plus buoyant force is density of air, because it is due to air. The buoyant force is due to the air, rho of air into g into volume of the fluid displaced is equal to volume of the body is equal to weight of the body, that is density of the body, into g into volume of the body. So from here we can find out maximum constant velocity, that is called as terminal velocity, with which body will have a downward motion. There is no further increase in the velocity. That maximum constant velocity is called as terminal velocity. I hope this is clear. See you in the next such video. Till then, enjoy, take care, and have a good day and a great future ahead. Thank you very much.